Hi guys, my name is Ernest. I'd like to welcome each and every one of us to my channel of Ernest Sciences and Mathematics TV channel. Today's discussion we are going to look at or rather even powers of the trigonometric functions of the sine of x and cosine of x. And this is going to, of course, assist us find some ways of trying to evaluate integrals of trigonometric functions that are basically having the even powers. So in this case, I've given an example of the cosine, the square of the cosine over x. And this is going to assist us, of course, try to find ways in which we can be able to evaluate integrals that consist of even powers. So in this case, I'm going to use a few rules which are applicable insofar as these even functions of or even powers of this sine and cosine of theta are concerned. And as we go ahead with the various discussions on this specific concept of integral of trigonometric functions, we're going to give other rules which are going to assist us, of course, achieve the same for finding the integrals of those specific functions. So in our discussion, we're going to see that there are some specific rules which are going to be applicable, and these are going to be the double angle formula rule, which we're going to apply in some way or another along the way in evaluating this specific integral that I've given on the board. So this double angle formula states that the square of the cosine of x is going to be given as a half 1 plus the cosine of 2x given as such. And this, of course, is going also to be applicable to the square of the sine of x, which is going to be given as a half 1 minus the cosine of 2x given as such. So in this case, this is not a square but a coefficient I've given for 2x. So therefore, this is the first and the second one for the cosine, the square of the cosine of theta, or rather x, and the square of the sine of x are referred to as the double angle formula, which we're going to apply in one way or another. So next we have this specific case for the this specific identity, whereby we have said that the square of the cosine of x plus the square of the sine of x is going to give us unit, and we have applied this one in some of our discussions in one way or another. And then third, we're going to see that for the cosine of 2x, this is going to be given as the cosine, the square of the cosine of x minus the sine square of the sine of x, given as such. And lastly, we're going to see that similarly for the cosine of, so this is going to be number 4. So for the sine, the square of the sine of 2x, or rather the sine of 2x is going to be given as 2 the sine of x, and then the cosine of x given as such. So these are some of the formulae that we're going to apply in evaluating this specific integral of even powers using the example of this cosine, the square of the cosine of x. So the first one is the double angle formula that's going to consist of these specific two equations. And next we're going to employ the concept of identity, and the cosine of 2x and the sine of 2x are given as such. So their specific values are going to assist us particularly evaluate what we've given in the board. Now, I'm going to do away with this, but in one way or another, I'm going to remind us of which specific formula we're going to apply as we go along. So our first case in this specific integral, we're going to apply the double angle formula for the cosine, the square of the cosine of theta, which given us the cosine of theta, the cosine the square of the cosine of theta can be given as a half 1 plus, of course, said that this is the cosine of 2x. So we're going to do a substitution for this cosine of x using this specific double angle formula as our first step, whereby we're going to have the integral being given as the half into 1 plus the cosine of 2x dx given as such. So we have just done a substitution for this from this double angle formula rule that we had studied before. So the next step is that we are going to apply this the multiple rule for this specific constant of a half that we're going to see here. So we're going to take a half outside this integral sign and have the integral of this specific function for the y plus the cosine of 2x dx given as such. So whenever we're doing addition of integral functions as such, we can be able to it's going to assume a distributive property whereby we're going to have the integral of the first a part of this specific expression and the second one. So therefore, this is going to be given as a half the integral of this first one, which is 1 in x, of course, plus. And this second one is as well going to be a half the integral of this specific cosine 2x dx. So if you try to look at this specific expression for the two integrals, the first one we're going to have it being represented as the value. The integral for one is going to be x, so therefore this is going to be given as x over 2 for the first part, and then we're going to have this one plus. So for the second part, I'm just going to write it so that we can be able to do a continuation of this. So the cosine of 2x dx. So we had stated that from the our previous discussion, we decided that we can be able to do a substitution for this particular value for the cosine of 2x by trying to give a substitution for u, which is going to be a function of x. So instead of using the values that we had stated for the cosine square of x minus the sine square of x, we can be able to say let u represent 2x. Then we can write it as du over dx is equivalent to 2. So implying dx can be given as du over 2 in this specific case. So therefore we can be able to write this first part of or rather this our integral as x over 2 plus a half the integral of the cosine of u du. Remember, du is equivalent to over 2, so we can be able still to take this particular constant out for a half, which is going to give us x over 2 plus a quarter the integral of the cosine of u du. And we said that the cosine of u du is going to be equivalent to the sine of u. So therefore, this is going to be a quarter to the sine of u, and then plus c given as such. So this is going to be an arbitrary constant which is independent of the sine of u. Now in trying to look at this, we have said that let u represent the 2x. We're going to restore this value for the 2x being given as this specific point. I'm just going to use the lower part of this. I hope it can be seen from there. So we're going to have this one represented as x over 2 plus a quarter the sine over 2x plus c represented as the answer for our integral over this specific even powers for the sine and the cosine of x represented as such. So do a cross checking of this specific evaluation, and maybe if there is a variation or a difference or some kind of a misplot that we have done along the way, you can give us in the comment section so that we can have other ways in which we can be able to solve this. So I hope that this specific step is elaborate. Especially I wanted us to understand how we can be able to do a substitution for this double angle formula and other related substitution formula, of course, or steps that we had done earlier in order to find the integrals over these even powers of the sine and the cosine of theta. So we're going to do more examples on this, and check in our description boxes for various videos which are linked to this, and of course some of the examples that we're going to do, specific examples we're going to do over the same. So that is it for now, guys. Bye. God bless you.